Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our Modern C++ series. In this lesson, we're going to be taking a look at the algorithm library, getting into the non-modifying sequence algorithms. So this basically means that we're able to look at some container, a vector, a list, whatever it is, and maybe ask some question about it. That is, what we're going to look at today is search in particular. So we want to be able to find some elements, or maybe some range of elements, or maybe ask a question about if two elements are next to each other and identical. All right, so with that said, let's go ahead and take a look at the CPP reference page here and have it guide us. So we'll go ahead to the algorithm library. Gonna go ahead and scroll down here. Now, for a bit here, we're gonna be ignoring some of the C++20 ranges stuff. Again, we gotta talk about ranges first, but let's just go ahead and look at some of these algorithms here. Now, in particular, I wanna be focusing on search for this video. So that means things like find. Let's see, we have search here as well. And we also have adjacent find, okay, which has the keyword find here. So if we just kind of control F for anything like search or find, that's what we'll do. Now, again, the key is that these are non-modifying operations, so we're not destroying or changing our data structure in any way. Okay, so let's just go ahead and start with find here. And as I noted in the previous video, depending on your data structure, like if you have something like a set or usually something that has a tree-like internal structure, you might have a member function available that you should just call on that container. Again, it's going to be a little bit more efficient. But with that said, let's just go ahead and start with the find algorithm here. Let's go ahead and take a look at it here. Again, we take in an iterator here for where we want to start looking, an iterator for where we want to stop looking, and then a value that we want to find here. Okay, so two iterators form the range that we're going to be searching between. Again, sometimes it's useful to illustrate this. So I might have some vector data structure like this here. Let's go ahead and put in some numbers, 1, 3, 5, 7, 9. And maybe I just want to look at, within these ranges here. So this could be my vector begin and my v begin plus 2 here. Okay, 2 hops over. Okay, and that forms my range here where I want to form some search here. And let's go ahead and see, is the element 3 here. Okay, and that is effectively find here. Okay, that's the idea. All right, so let's go ahead and I'm going to leave the CPP reference page up here. Let's try to use this again for pretty much a lot of the next videos here. We need to include, we can make this bigger for now, the algorithm library here. Let's go ahead and let's work with vectors for most of these. I think that'll be nice here. You can work with vectors or strings are fun to work with. For these examples, let's create a vector v, and let's go ahead and initialize it 1, 3, 5, 7, 9, something like that here. Let's go ahead and try to compile this. And since it's missing our template arguments, well, okay, let's go ahead and give ourselves a little bit more power here. C++20. So we could do template argument deduction. But in general, and as others have noticed, I usually like to specify my template argument. Okay, so anyways, that'll set us up with a vector here. Now let's go ahead and do an experiment here where let's try to use find. So let's use std find. Let's go ahead and look from v begin, v end, and let's go ahead and see if 7 is here. And what is this returning to us? It's giving us an input iterator here. Okay, that's what it's returning here. So let's actually read this here. Returns an iterator to the first element in the range. So again, this might be a little bit of a strange pattern. We have seen this before when we looked at our containers. But let's go ahead and take a look at how to handle this. And we'll have to sort of remember, what does it mean if we didn't find something? Okay. Well, it means that we basically didn't reach the end, or excuse me, I should say we did reach the end here of our actual range here. Okay, that means that we didn't find it. So let's play around a little bit with find. I think it's a nice example to look at. Here's the start, the value. I think I'll wait to talk about policies until a little bit later here in the series. I'll push that off just for now here, but let's go ahead and start with this here. Okay, so let's just go ahead and see if this compiles. This is fine. It's not going to do anything useful. Let's go ahead and see our result here. Okay, so let's go ahead and do something like this here. And then how do I determine if I found something? Well, again, let's just play around with this here. Let's say if result is not equal to v.end, then let's go ahead and say found 7 in this case. I'm just going to hard code it. Okay, so let's go ahead and play with that. Let's go ahead and run it. And we did indeed find 7. Okay, so that's great here. Let's go ahead and see, were we able to find 8 here just to make sure this works? Try out both cases, and nothing's printed out here. Okay, so that's how that works here. Now, a few things to keep in mind here. These iterators here, beginning and ending here. We're not modifying anything, so can I use the const ones? Well, let's go ahead and give that a try here. See if it still compiles. Still compiles fine, right? We're not changing anything. This is a non-modifying operation. Probably a good thing to signal, again, just to ensure that nothing's being changed, that we have these const iterators. It does change our return type here, something to keep in mind. Just keep that, or I should say this doesn't change our actual return type, actually, in this case here. It's still returning us the same iterator here. Now let's go ahead and play around with this just a little bit. Let's just say, for instance, that I only want to search this range here. So let's just do 1, 2, or excuse me, 1, 3, and 5 here. Okay. So again, I'm going to do v begin, and let's see if I find that 7 here. But I only want to look, at these 2 elements here. Okay. So go ahead and compile this. Oops, it looks like it's I mixed these up. You can't mix the const and non-const here. Here, we'll just leave them as begin. Let's go ahead and try that out. We found 7. It says we found 7. Okay. Well, what's the iterator that we actually return here? Is it not equal to v.end? Okay, let's go ahead and modify this. If it's not equal to v begin plus 3 effectively. Okay, so 1 beyond our search point. Okay, let's go ahead and try to compile that again. It says found 7. Oops, maybe I got my math wrong here. Let's see. You begin. Okay, didn't find it here. So let's kind of walk through this again, just so we can, if you want to just be able to search a small range of it, let's make sure that we're doing this correctly. I'll kind of just walk through this because, again, when I'm supplying the end range here, that's that's where we're terminating, right? So this is begin plus 1, begin plus 2 here. Okay, so that's my ending range here. Okay. So let's go ahead and play around with this just to see if it works here. Let's see, are we able to find 5 here? Okay, I got to change our printout here. Here, all right. So let's go ahead and compile. Let's run it. And yeah, not able to find 5. Let's see, can we find 3? Yeah, let's see. We should be able to find 3. Okay, yep. So I might be off by 1 here because, yeah, this is the end, which again, end is sort of plus 1 beyond our data structure. What I'm really doing here is giving myself this range. I'm really looking at just 1 and 3, and my iterator ends at 5 when I'm doing begin plus 2. So just keep that in mind here when I'm specifying this as my end range here. Okay, so most of the time, though, however, I'm just going to get rid of this experiment. I just wanted to show something that's, not usually shown. You'll want to play around with these things just a little bit here. Usually you're going to be looking through the whole range, but occasionally what you'll be doing, and again, there's algorithms for this that are great, maybe partitioning your set. So you could partition it by doing find and kind of subdividing, but guess what? There's an algorithm for that we'll get into later for, breaking up or returning a new set half the size. So anyways, that's find here. Let's look at a few of the other operations here that are available. And the other thing to notice about the algorithm library is you're going to find like find and then find if not. So multiple different versions here. So let's just go ahead and look at find if here. So we got to find it. There it is. And again, it's a templated data structure here. So how to read this? Well, the class itself looks pretty familiar here that we've seen. before. Okay, so this is just sort of our iterator type, but it's got this extra thing here. Unary predicate here. Okay, so what does that mean? So we have our, if I'm looking at find if, our first, our last, and then it has to satisfy some predicate here. So some actual condition. Okay. And I'll actually make sure, you'll see on occasion that these are changed here because they basically added the const expr version in C++20. So I'll try to actually highlight the one that is available. It's not really going to make any difference as we're learning this stuff for the first time, but I think this is still useful. So let's go ahead and look at find if here. Let's go ahead and take a look at an example here. Let's see if we can find if and how it works here. So here it is in the code here. Here's kind of a common pattern that you'll sometimes see, this sort of if auto, iterator, find if, and then we've got some predicate here. So we're looking from the beginning to the end, and then it needs to satisfy some condition here, okay? And this is where lambdas in the language come into use, or functors, as they're sort of implemented behind the scenes. But this is the predicate, so something that is satisfied. So that means, the signature of this function is auto, but really it's a bool, doesn't return true or false. And I'm looking to the beginning to the end to find if there is something that is even here. Okay. Okay, so let's go ahead and try this out here. I'm going to leave this as an example. So let's go ahead and just call this our find experiment. And let's just go ahead and comment this out here. But I'm going to reuse parts of it. And let's go ahead and modify this. So let's find our value and do find if here. Okay. And we're going to need to write some sort of function. Let's bump that up here so you can just see the signature correctly displayed. And let's do auto. Let's repeat this. Let's just do is even. So this is the function here. We're looking at each of the inputs, so that's why we've got one argument here. So basically, we're just looking through each and every individual element. That's effectively I here. And then what we're testing here is we're going to return I mod to, oops, equals 0. Okay, that's for an even function here. Okay, so there it is in 2 lines. Most of the time, folks are just going to write this out as a one-liner, so let's do that here. And we could probably even just, if we want, you'll also see this pattern where folks just take this and plop it in to the argument here. Okay. So let's make sure we put this in the right spot here. Find if the beginning, the end is even here. And we've kind of got everything crunched together, so I'm going to move away from here. But let's get rid of this. And our signature, oops, let's go ahead and see our signature. That's what I was trying to look at. We're not really looking for a value here. Again, with find if here, we're looking to see if we find something that satisfies that predicate. Okay. Am I able to find, something that satisfies this here? So find if here, this is number 3. Let's again understand how to read this. So I'm looking at section 3, let me highlight right there, and then section 3 down here. I'll make it a little bit bigger here. Find if searches for an element for which the predicate P returns true. Okay, so it sounds like at least one here. Okay, and then find if not does the opposite thing. Okay, for which the predicate returns false. Okay, so depending on what your situation is, I guess you could use one or the other of these. I'm probably just going to use find if and probably invert it. But let's go ahead and run this here. And we could go ahead and sort of say the same thing. But we're going to restate this as could not satisfy is even. Okay. So this is going to return true. Again, find if searches for an element which the predicate P returns true. Okay. So that's what we're trying to satisfy, this condition here. Okay, so let's go ahead and just take a look at that. Let's give this a compile, see if I did anything silly here. Nope. So again, we have our little lambda function here that's going to check all of our elements and try to find some element and find if it satisfies this condition here. Okay, so let's go ahead and run this. Did not find anything that's even. So let's go ahead and play around with this here. Let's add 10 here. And now this should return true. Okay, recompile, rerun. Oops, and I should write this as could satisfy because it's returning true. There we are. Okay, because the result's not equal to end. Because again, result is going to return the iterator. It's looking through every single element here. And let's go ahead and print out our result here. Let's see if we remember how to do that here. If I just print out the result, remember that this is an iterator, which again, this is reviewing some of our iterator videos. Remember, an iterator is usually just this idea that we have a pointer and it's sort of encapsulating or hiding from us how we're moving from one element to the other. Let's just see what this prints out. Ask yourself carefully, is this going to print out the value? So no, it's not going to like that here. Let's give us a bunch of garbage here. Let's just here dereference it and make it work. So I gave us a bunch of stuff here. Remember that this is effectively, it's not always a pointer, but you know, it's, I guess it's always looking at some piece of memory here. But if we want to look inside our result and find out what is the thing that satisfied this condition, let's go ahead and run it, and we get 10 here. Let's go ahead and see if we put you know, like 12 here earlier on. Is it going to give us 12 or is it going to return us both here? Okay, go ahead and run it here, 12. Okay, so it looks like it's just going to return searches for a single element. Let's go ahead and see the complexity of that. For 3 at most n applications of the predicate. Okay, so at most it has to look at everything. It looks like this is just which would make sense, returning the first thing. Okay, that's what the iterator that you get back. Okay, so that is Findif. Okay, let's find a few more of these search things here. Okay, so that's Findif, not modifying the sequence, just returning us again some sort of information here. Okay, let's see here what we have here. Let's go ahead and look at search here. Let's open this up here. Let's see what the pattern is here. We'll look at the const expr version here. So I'm going to look through the first, the last, and then the first, and then the last here. Okay, so search sort of sounds like find. So very similar, but let's go ahead and read this description. Searches for the first occurrence of the sequence of elements. Okay, so that's kind of interesting. In this range from first to last. So find, you can imagine the use case. Let's go ahead and document some of this as this video is getting a little bit long here. It's sort of for existence of an element. You know, do I have some value in my vector? Okay, you're just kind of looking for something. You know, and doing a linear search here. Search, I would say, is more like what I might use it for is like a string or something, and looking for like a range here. Okay, so maybe you're doing you know, some like genetic sequence or something, you know, using these here, trying to find like something, some sequence that exists. That's probably more what I would use this for, and just thinking off the top of my head here. But that's the idea here. Let's go ahead and see a use case of search, and then we'll practice it here. We can see how it's used here. So it looks like I have some container that I want to look from the beginning to the end and look for some sequence here. Now it looks like they're doing string matching problems here. Let's do it with vector, just because that's different. But let's go ahead and play around with this a little bit. And let's go ahead and create ourselves a vector of int v1, 2, 3, 4, 5. That'll do the trick. And then let's just go ahead and let's do our search auto. Now again, remember what auto is giving us here. I'm just going to call this result here. Auto is giving us an iterator that's going to look something of the form vector int iterator, something like that here. Okay, that's our signature when I'm using auto. I can leave that there. And let's look from the beginning to the end. And the sequence that we're going to be looking for, let's go ahead and see here. So we need some other container here. Okay, so where we're sort of searching and ending here. Now here they're using a string and they're passing in. They wrote this nice function here. Let's just go ahead and say vector here, our sequence. Well, let's go ahead and start with 1, 2, 3. Okay. Actually, let's make it a little bit more interesting. 2, 3, 4 here. Okay. So can I find 2, 3, 4 here? Okay, 2, 3, 4. There it is. In this case, yeah, we would expect this. So let's go ahead and see if that works here. And I'm just going to look for the whole sequence. Let's see here. S here. Sequence I'm looking for in my vector v. Okay, just so that's clear what's going on there. S in the beginning to the end. Okay, so I want to find out if this is a subset of here. Okay, and let's go ahead and write out our result. So same pattern. If result is not equal to what is this returning here? Is this the same thing? Oh, looks like actually we're getting just a Boolean value here. Is that what's returned? Let's go ahead and see this here. Searches for the first thing. Let's go ahead and try it out. This is just returning. Oh, if it's not equal to the end. Yep, same pattern as always. And that's a important thing. Now they've nicely sort of encapsulated this in this example to just return a bool here. But again, most of the time with our iterators, we're just looking to see, did we iterate and iterate and iterate and then reach, one past the end, which is what the end iterator represents. And if we did reach that, that means that, well, yeah, we're out of luck here. We didn't find our result here. And the thing that we're looking at, again, is our container, okay? So it's doing the hard work, if we look at this, of effectively, in our example with 1, 2, 3, 4, and 5, of checking this sequence here, 2, 3, and 4, and saying, okay, does that, do we have a match here? Okay. It says no, and then we kind of slide over here and do 2, 3, and 4. Okay, and then we look here. Here we will get a match here. Okay, so this is sort of a sliding window strategy, maybe for some of those folks who've done, leak code or that kind of thing here. Let's just leave that there. That's the idea here. Okay, so if the result does not equal e.end, we found our sequence. Okay, let's go ahead and print that out. Let's make this a little bit larger here. It's getting a little bit messy. Let's give it a compile. Whoops, looks like I made one spelling mistake here. Vector. All right, that's spelled right here. What else did I do? Nothing. Okay. Okay, so here's all the code. Let's give it a try. And we found our sequence. Brilliant. So again, let's just try to change this. Is there, 2, 4, 4? Is this whole sequence, can we find it here anywhere? Let's go ahead and run it. We cannot. Okay, so that's the idea here. I'll go ahead and leave the positive one here. Some of you might have done like Knuth Pratt Morris, like string search. I think there's an example of another string search in here. Yeah, Boyer-Moore searcher here. So there's all sorts of, optimal string searching algorithms that you can look at in this example, but that's the idea with search, okay? So let's go ahead and look at some more non-modifying things here. Let's look at adjacent find. That's a little bit different, and then we'll go ahead and wrap this up here. Let's go ahead and figure out how to read this first and foremost. And the idea with adjacent find, again, let's look at the const expert version here. So number 1 here is elements, searches the range from the first to last for 2 consecutive equal elements. Okay. Okay, sounds reasonable enough here. Let's comment this out. And we'll go ahead and continue our search here. Vector. And for this, we're just going to set up 1, 2, 3, 4, 5. 5. 6, 7, 8. Okay. So adjacent find. Where are there 2 adjacent elements? Here's 2 right next to each other that match here. Okay. Let's go ahead and do our search here. Adjacent find. And I want to look from the beginning. I'm doing this. I'm not going to look at the documentation, so I might mess this up. Let's just see if we find the elements here. So I'm just sort of guessing at this point. And you'll get kind of used to this with using the algorithm library here. You know, here's my range here. Same pattern here. If result is not equal v.end. And it's not that we want to be robotic. We need to think about this here, but simple enough example. Let's see. Found in adjacent pair. Okay, and let's go ahead and print out the result here. We'll want to look and see exactly which, does it respond to the first one. We'll play around with this a little bit, but let's see if this compiles, and we did find an adjacent pair, 5. Okay, and let's go ahead and maybe add in a 2. Does it give us the first one? Sure does. Okay, so that's kind of neat here. And let's go ahead and get rid of these here. Let's put 7, 9. I don't know, some random numbers here. And did not find it here. Okay, so that's the idea with adjacent find. Super useful. Some of these algorithms that we have here can be useful for things like filters and image processing. There's going to be another one, adjacent difference. That's kind of neat. Median, some of these other algorithms that are kind of nice here. But again, basically what this is doing is looking through your data structure and just keeping track of the previous element here and seeing if it matches here. Let's look at the complexity here. So let's see here. So exactly the min of, well, whatever range you're looking at, the first thing through the last. So it's sort of basically a linear algorithm. You got to look through everything and see if there's a matching pair here. Okay, so that's with adjacent find here, finding 2 consecutive equal elements here. Now, if you're using a custom data type, and if folks want to see these things with custom data types, again, you just got to make sure that you've overridden the equals or the equality operator so that we're able to use that. Okay. Let's see if there's any other interesting examples. Yeah, you can kind of see the loop here, but again, this is the type of, this is a great maybe way to wrap up this video and say, here's a possible implementation here. I've actually got a couple here. But what's nice is it handles the case here. If the first thing is equal to the last, you just return the last here. Okay, so that's actually an interesting use case. This could be something. What if I just have the number 8 here? Does this, return that I found something adjacent? No. Okay, so it handles this use case here, where it just returns last, which would be your end iterator, so we're done. Okay, so you don't have to worry about that edge case if you have like less than 1 item or an empty set and so on here. Okay, otherwise we move forward and we're sort of keeping track of our first element here. Let's see, moving forward and keeping track of our next element here, and then just seeing if they are the same value when we dereference them. So a nice enough thing, but if you had to write this twice in your code, getting the little pointers, correct and stuff is a little bit, you could do it. You can certainly do it, but this is already built in for you. Okay. So anyways, that's adjacent find, which is kind of nice. And I'll actually add one thing, because this is a nice thing. I was just looking at this code here with distance, because we looked at distance earlier here. Let's go ahead and add that in here. At index. Let's go ahead and put this in here. The distance would be from our beginning to our actual result here. And we'll actually check that out here. This will tell us where we found it at index 5. And I say just because I don't like when the numbers line up here. Let's make these 9s. Okay, this is just general stuff when you're learning it, right? You want to make sure we'll actually count these out here. For our data structure, this is at 0, 1, 2, 3, 4, 5. Okay, so it's returning the first element here. Okay, so that's the index here. That's the adjacent pair. Okay, so that's an example of some of the non-modifying sequence operators, specifically in the search example. Now, this video is getting a little bit long, so we'll look at some of the other things in the non-modifying sequence operations in the next video, so make sure you're subscribed so you don't miss that. You can track your progress. There's going to be a bunch of these on my website if you want here. And otherwise, folks, I hope you're enjoying this, sort of deep dive into algorithm, and just play around with it. Have fun. You'll get used to some of the patterns as you know or learn that these things exist. I think they'll help you write some better code. All right, folks, with that said, thanks for your time and attention. I'll look forward to seeing you in the next one.